Okay, compound inequalities and absolute value inequalities. So a couple comments before we even work a few. It's maybe not the best way to title this because absolute value inequalities are a type of compound inequality. So all absolute value inequalities are compound inequalities, but not all compound inequalities are absolute value inequalities. Kind of a squares and rectangles thing, right? Like this is the rectangle, and the specific type of that rectangle is absolute value inequalities. Now, you handle them kind of differently, so that's not too big of a deal. Let's do compound first, because that's not too bad. It works like you think it would work. Absolute value, that's very different, so we'll pause when we get there and emphasize some things. But first, the compound inequalities. And our instructions will be solve and graph. And you know what? Why don't we just go ahead and add interval notation as well. Keep that fresh in our brain. Solve, graph, interval notation. Okay, someone's going to have to fill me in on the details, but compound sentences, grammar, long ago. What's a compound sentence? And it doesn't have to be perfect. It'll be close enough because it's just an analogy. What's a compound sentence from English? Do you remember? Okay. Two sentences made into one. I think that's right. That's what a compound inequality is. Two inequalities made into one. So you're familiar with compound sentences. Compound inequalities share some of that same idea, like instead of one sentence it's two, but they're joined together. That's a great way to describe compound inequalities. It's two inequalities, but kind of squished together into one. 28 is less than 4 minus 3n is less than or equal to 34. Is less than 4 minus 3n is less than or equal to 34. So I think you can see, I hope you can see kind of the analogy there. The left-hand side, that's one inequality. That's pretty easy to work with. If you take the middle piece and pair it with the right piece, that's another inequality. But we shove them together to make one long inequality. That makes it a compound inequality. The good news is we solve compound inequalities like we solve equations and all the other inequalities. We want to get n by itself. So what do you think we should do first to start to get n by itself?
Separate the one inequality statement.
We're not going to break apart the inequality. We're going to leave it as one compound inequality. No, I don't want to add 3 because if I want to separate the 3 from the n, those are multiplied, so I need to divide. But I don't want to even do that yet. Let's subtract the 4. And here's the weird thing. Usually we subtract the 4 from both sides. Where do you think I should subtract the 4 from?
Both sides. Like 28.
Yeah, all three sides. Right? There's 3 parts to this inequality. And so we're going to subtract it from all 3 parts. 24 less than negative 3n less than or equal to 30. Okay.
Now you divide negative 3.
Now we'll divide by negative 3. What are we going to divide by negative 3? Obviously the middle to get n by itself. Everything, yeah. Everything. And then, yes, we'll flip those inequalities around because we divided by a negative. So greater than n, greater than or equal to negative 10. That's a true statement, and it's kind of correct. But we like to have our smaller numbers on the left. Like we like to go from from smaller to bigger. So I'm going to rewrite this, but I want the negative 10 to start us off because that's the smaller number. So one way to sort of phrase this is I'm going to read this thing backwards. I'm going to start at the negative 10. And how is negative 10 related to n? Less than or equal to. Okay? Again, if you kind of put your brain or your eyeballs this way, looking that way, you would say negative 10 is smaller than or equal to n, which is less than negative 8. And I put it right there because it kind of mirrors over. So some people see it like visually, like in their brain, like reflect it over, and you got the mirror image of it. Other people sort of just read it backwards. Negative 10 is smaller than n, which is smaller than negative 8. Okay, so we've solved it. Now let's graph it. It's also easier to graph when you go left to right, smallest to biggest, because if you don't flip it around, someone's number line is going to look like this, and you can't, right? That's a backwards number line. The smaller number's got to be on the left, so don't do that. So flip it around. That'll help keep your number line in order. Okay, I want numbers that I want my n's to be bigger than negative 10. So that'd be this way. But I also need them to be smaller than negative 8. So that would be that way.
Creates a line. Yeah, kind of.
I wouldn't say a line if you want to use a geometry word. It's more like a line segment, right? Because it's only the stuff between negative 10 and 8. Also need to be careful. I skipped over the open circle, closed circle thing, but open circle, closed circle. So it's the stuff between negative 10 and negative 8. Because it has to be both smaller than negative 8 and bigger than negative 10. So it's only the stuff in between there. Which sort of makes sense because you've got n like literally written in between negative 8 and negative 10. So it makes sense that your solutions are between negative 8 and negative 10. Interval notation, negative 10 to negative 8. Okay, hopefully that's not too bad. The only thing new is instead of 2 sides to the inequality, there's 3 sides to the inequality. But all the other rules are the same. So that's not too much of an extension to what we've already done. In fact, you may have done these in Algebra 1. What I don't think you did in Algebra 1 are absolute value inequalities. Okay, so this unit we've done absolute value equations. That was last Friday. Split them up, set them equal to the positive and the negative. We've done inequalities. We just did an example of that. Now we're going to put those two ideas together. And so this is where people start to get confused, right? Because if you're good at absolute value and you're good at inequalities, it's still kind of confusing to put them together. If you struggle with either or both of these, then putting them together is really bad. Let's back up. How did we solve absolute value equations? So don't worry about the inequalities yet. What did we do first if we're solving an absolute value equation? You remember what we would do first? Get the absolute value by itself. That's the same step. So we want to isolate the absolute value. So get that, right? I think we used a pink box. Like get the pink box by itself. Isolate the absolute value. So that matches. That's the same as, that's how we handle absolute value equations. Get the absolute value thing by itself. What did we do next when we did absolute value equations?
We broke it up into 2 equations, one equal and negative and one positive.
Good. We broke it up into two pieces. Well, we're going to do kind of the same thing here. We're going to write 2, but now not equations. We're going to write 2 inequalities. And I guess just to make this one step, write and solve 2 inequalities. So if you know how to do absolute value equations, it's not too much of a jump. There is an extra step we'll get to in a minute to get to inequalities. Get the absolute value thing by itself, split it up into 2, and we're even going to do the plus minus thing. There's going to be a little bit of trickiness with the less than, greater than, but we'll do that in a minute. So we handle them differently. First, the less thans. We handle less than different than we handle greater than. And that's a little bit weird because we've never done that before. I mean, before it didn't matter. Like you just worked the problem, it didn't matter if it was less than or greater than. Maybe you switched it, but it just did the same stuff. These we handle different, so we'll have to be careful here. Let's do like as simple as one as we can get here. Absolute value of x is less than 4. Might be hard to write one simpler than that. Step 1, isolate the absolute value. Yeah, check, we did that. They gave us one that was already isolated, so we're good on that. Step 2, write 2 inequalities. Okay, well, just like the first equation was just drop the absolute value bars and don't do anything else, same thing here. Our first inequality is just drop the absolute value bars. Don't worry about anything else. And that word's important because it's and, not or. We'll talk about that more in a minute. And what did we do with equations to write the second?
Negative.
Okay, negative 4. I left the blank there, though.
Open side.
Right? When negatives are involved with inequalities, you end up having to switch around the sign. So we're going to make it greater than negative 4. And what I will often say is change both signs, meaning the sign of the number and the inequality sign. So, new process, but some strong similarities with absolute value equations. Right? First one, just drop the absolute value bars, move on. Second one, change the sign to negative, but also change the inequality around. That kind of fits. When you're dealing with negative signs and inequalities, you frequently have to flip things. Okay, well, those are already solved for us. That's kind of nice. So I want to know where x is less than 4 and, like, meaning they both have to be true. X is greater than negative 4. So let's put them on a number line, and we'll look for the overlap because I want them both to be true. Okay, this may seem simple, but make sure you put those in the right spot on the number line relative to each other. Right? You make sure negative 4 is left of 4. Both open circles. Okay, let's color code this. So less than 4 means we'll start at 4 and go that way. Everything less than 4. Greater than negative 4 means we'll start at negative 4 and go that way. And I want the set of numbers that are true for both the pink and the blue. I need both things to be true, so I'm looking for the overlap. And obviously, if you've graphed it right, well, it's easy to see the overlap. It's just the stuff where both pink and blue are. So negative 4 to 4. Parentheses, right? We don't want to include the endpoints. Let's try another less than example. This time we'll step up the difficulty a little bit here. Negative 3, absolute value 2x plus 1, minus 4, greater than negative 37. Sickle sticks? You want me to call on people? Is that what you're asking for? I mean, it's only our second one, and this is kind of confusing, so I don't know if we want to go there yet. Well, first off, big picture, like this is, I said this is a less than problem, but it sure looks like a greater than problem. Anyone peek ahead and know why this is secretly a less than problem?
It's going to end up flipping.
Why is it going to end up flipping?
Because you divided by negative.
Yeah, in a minute we're going to divide by negative 3, and that's going to flip it around. So that's a good reminder that we don't categorize the problem until we've got the absolute value thing by itself, or unless we can peek ahead. So let's get the absolute value thing by itself. That I don't mind calling on people for, because that we've done plenty of times. Find somebody who's here. So it looks to me like there's two things I need to do to get the absolute value thing by itself. So, Ocean, what should we do first? I would add 4. So, negative 3, absolute value, 2x plus 1, greater than negative 33. Aiden, what would you like to do next? And when I divide by negative 3, flips the inequality. So, absolute value of 2x plus 1 is now less than positive 11.
Anytime you have the line with the absolute value thing, you can drop them, right?
Now I can drop them.
Okay, no.
Don't drop them until you've got it isolated. Yeah, and then when you say drop them, that's the part of splitting them up. When it comes time to split them up, step 1 is drop them. Yes. So there's my first equation, or my first inequality, excuse me, is just drop them. Don't overthink things, just get rid of them. I don't have to factor the 2 out. I can handle the 2 from here. I mean, if there was like a 4 there or a multiple of 2 there, you could, and maybe that would make things easier, but it's not going to be easier on this one. So what's my other inequality going to be?
X greater than negative 5.
2x plus 1, and then greater than negative 11. Change both signs. So we switched it to negative. That we're used to doing that part. That's from the equation part. And then we also have to switch the inequality. And this may not seem important now, but the word that goes in between there is very important. And I need both of these things to be true. Okay, well now, just like equations, you split it up and you solve 2 easier equations. We split it up and now we'll solve 2 easier inequalities. I'm almost out of room, so I'm going to do both steps at once here. Subtract the 1. And that gets me 10. Divide by 2, I get 5. So x is less than 5. A little bit harder with negatives here. X is greater than negative 6. And I need both things to be true. So let's graph it, look for the overlap, and then write our answer. Again, make sure that you put them on the number line correctly. I mean, maybe that seems simple, but every year somebody makes that mistake and it kind of messes up the rest of the problem. Okay, so greater than negative 6. So I'm going to start at negative 6, and I want bigger than negative 6, so that would be to the right. And then less than 5, so I start at 5, and I want less than 5. less than 5. Most people don't end up doing the color coding silliness, but other people use the colors the whole year and draw them and use the colors even on the test. And if you need to, that's fine. If it helps you see that, hey, I'm looking for where the pink and the blue solutions are, well, pink and blue happens right there from -6 to 5. Okay, but all of that was, both of those examples were less than problems. So, what do you think letter B is going to be? Greater than problems.
Oh, is this where we have to like do the U thing? Like,
So if there's two solution intervals, yes, we'll join them with a U.
we have to do like 5 U.
And then 7 to infinity or something like that. So yes, if that happens, we'll use the U. And yes, it's going to happen. Let's do that similar example, super easy one here. Or maybe not super easy, but as easy as we can get. It's still good here, just didn't want to go. There it is. Absolute value of x greater than 4. Step 1, isolate the absolute value. Check, we did that. Step 2, split it up. What do you think, George? This is kind of putting you on the spot. So I haven't even done one of these, but we'll trust George. What do you think my first absolute value, or we're dropping the absolute value. What's the first inequality going to be? It fits the pattern that we did with equations and we did with less thans. When it comes time to split it up, all we do is drop the absolute value bars for the first one. So what's my first inequality going to be?
Would it just be, should I just drop like the absolute value on the x,
Yep.
and then it'd be less than 4?
Well, drop the absolute value bars. You don't drop the x. So
X and less than, or no, it's greater than 4.
that's all it is. Same with equation, same with less than. First one, just drop the absolute value bars. To get the second one, what do you think, Elisa?
X less than -4.
Yep, x is less than -4. So it's still that same idea of change both signs. So we made it -4 and we flipped the inequality around. Now the word that goes in between them is different because this is greater than, not less than. The last word was and. You know what the other word is we use to connect these things? Or. So that means I don't care about the overlap. I need the solutions that are in either solution space. Because greater than goes with or. Greater than always goes with or. Less than always goes with and. I'll give you a hint to how to remember that in a moment. Okay, so there's -4, +4. Let's see, greater than 4. That would be that way. Less than -4. Be that way. And I'm not looking for the overlap this time. I'm not looking for both to be true. This isn't an and problem. It's an either or problem. So now, Ben, what you said earlier about the U thing is going to...
Give a thing to all of the parentheses U. Parentheses again, 4 to infinity.
Yep. Let's do one that's a little bit harder than that. absolute value of x over 4 minus 6 greater than or equal to negative 2. Absolute value x over 4 minus 6 greater than or equal to negative 2. Let's see here. Scarlett, what do you want to do first? Add the 6. Because our first job is to get the absolute value thing by itself. So add 6 to both sides, we get 4. Okay, we've got absolute value thing by itself. Now it's time to split them up. So, Kinley, what's the first inequality?
X over 4 is greater than or equal to 5.
Yep, you got the easy one. You don't have to do anything except drop the absolute value bars. Mason, you've got the challenging one. What's the second inequality going to be?
X over 4 is less than or equal. X over less than or equal to.
Good. He changed both signs. Less than or equal to negative 4. Change both signs. And what's the magic word that goes in between a greater than problem? Or. Okay, so now we're going to solve both of these, and we'll be looking for where either or of them is shaded. So x is greater than or equal to 16, or x is less than or equal to negative 16. Let's see, negative 16, close circle, less than, positive 16, close circle, more than. And I'm not worried about the overlap. I'm looking for either. So I'm going to have to get all of that stuff, negative infinity to negative 16, and 16 to infinity. Whoa, what's wrong with my answer? Get going too fast. Need brackets. Great way to make a 98 on a test, something silly like that.
You made us so easy.
So the main difference between the two is the word that goes in there, right? The rest of it's the same. The setup is the same except for the word that goes in between there. So here's how you remember what word goes in between there. There are less than problems, like we just sort of combine less than and into one word. And the other types of problems are greater than problems. You just misspell greater problems. So less than, greater. Everything else you kind of already know. You know about splitting them up. You know about changing signs. So the new thing is what word goes in between your two statements. Less than, greater. That's the, got to get that right. Less than, greater. Okay, let's do one more. Absolute value, x plus 3, plus 5, less than or equal to 1. Absolute value, x plus 3, plus 5, less than or equal to 1. Haley, what do you want to do first? How do you want to get the 5 to the other side? Subtract it over. So absolute value x plus 3 less than or equal to negative 4. Alright, now it's time to split them up. Gio, what's the first inequality going to be? The first one, all you have to do is drop the absolute value bars. All you have to do is drop the absolute value bars. So keep that sign the same, keep that sign the same. All you do on the first one is drop the absolute value bars. For the equations or any inequality, first one, drop the absolute value bars. Angelina, the second one we got to be careful about. What's the second inequality? Good. Change both signs. Greater than or equal to, and then here's the positive 4 that's sort of there. Change both sides. Okay. Hard part's over. Oh, wait, what word goes in between there?
Or.
What word goes in between there?
And
Right, less than. So we put a and in between there. So that means I'll be looking for where both things are true, where the overlap happens. So x is less than or equal to -7, and x is greater than or equal to 1. So let's draw the picture, look for the overlap. Let's see, -7, close circle. Which way am I shading, left or right? Where are all the numbers smaller than -7? To the left. And then there's 1, close circle. All the numbers bigger than 1. To the right. I need where they overlap, but they don't.
So it's like NA.
Let's not say NA. I mean, I would accept that. The better mathy answer would be no solution. There's no place where they overlap. So this is kind of a special case that happens. But if you're paying attention, you can figure it out. It's no solution. There's no place where they overlap. The trouble with this one is people aren't paying attention to the and or the or, and they get this picture, and they're like, oh, -infinity to -7, and 1 to infinity. Like, nope, that would be an or problem. This is an and problem. Almost done. This is one of those where if you were really paying attention, you might have caught it earlier, and I tried to blow past it so no one would interrupt me and catch it earlier. Do you see where we might have caught this earlier to realize this is a no solution situation, Brooklyn?
We had to switch the negative to a positive instead of a positive to a negative.
Okay, it's related to that. We always have to switch it, so it's not the switching that's a problem. But you're close.
The first one, the first equation is negative. Like when you got the absolute value. Or the absolute value.
You're again on the right track, and you're really close, Ben.
The sides are like close to each other. Like that.
I mean that when you break up a less than, you're always going to get this one less than and this one.
You get the over to each other.
Okay, back up to this step. Somebody said it. Absolute value can't be negative. So I'm sitting here claiming that an absolute value of something is supposed to be less than a negative number. But absolute value, like at its smallest, is 0. It's certainly never negative. So if we're really paying attention, we could catch that and jump straight to no solution. Sort of like with equations. You can, if you're really paying attention, sometimes you catch it. Other times you're so focused on remembering the process and remembering the steps and greater and less than. Most of the time, and these don't happen very often, most of the time students miss that. They work the problem and then they get no solution. And then hopefully they realize, shoot, I could have figured that out 2 minutes ago. So, again, it's not really a big deal if you don't catch it here. You catch it eventually. But if your brain is really engaged while you're working, you can catch it earlier. All right, finally we get to use the packet again. Let's look at the packet. First period packet is somewhere. So, conveniently enough, the worksheet is 1.6, compound inequality, and absolute value. I guess we should add this to the title, absolute value inequality. Why don't you try number 1? Does number 1 have any absolute values in it? No. So be careful. The other the trick that some people, there's two mistakes people make. They forget about the absolute values and never write two inequalities. The other extreme mistake is to do the other thing and start writing two inequalities when there's not a reason to write two inequalities. When's the only time we're going to write two separate inequalities? When it's absolute value. So number one, you're just going to solve it as written. You're not going to need to write anything separate. So today, the only new thing today is greater less than. But it uses a whole bunch of stuff that we only recently reviewed. So I get where these are tricky. But the main new thing is less than greater. Everything else follows the rule that we already should know. Anyway.
You did number 2.
Sure. Number 2. Number 2 is an and problem, so I already know that I'll be looking for the overlap, because I need both things to be true.
Skip the whole process.
Well, it is a little bit like they jumped in midway on an absolute value problem. Yeah, it feels like that. But, so what? We'll take it from here, and we'll look for the overlap. Oh, I'm going to... I'm kind of conflicting reasons here. I'd like to subtract 2r, because then my r stays positive. But I'd like to subtract 3r, because then it's on the left. You got a preference? I got a problem either way.
Subtract 2r.
I'm going to subtract 3r, because I want my r's on the left. Well, you know what? Let's subtract 2r, because then I can illustrate why some middle school teachers, I don't like what they teach. I was going to say something mean, but I'm recording, so I won't keep it nice. Plus 3 to both sides, that gets 11. Minus 2r from both sides. 11 is greater than or equal to r. All right, let's go to the other one. The other one's set up better, meaning I subtract 8r from both sides and not have to flip things around. Subtract 9 from both sides. And again, it's an and problem, so I'm looking for the overlap. I'm glad you asked this, and I'm glad we worked it this way. So negative 4, greater than negative 4. So that's all the numbers to the right of negative 4 are the numbers that are bigger than negative 4. And then here's 11 with a closed circle. What did I forget to add? Oh, yeah. Thank you. And here's where some people are taught a shortcut that will mess them up. Some people, I don't know if it's middle school teachers or people coming to this shortcut on their own, they think, oh, I'll just shade which way the thing points. If you don't like that, good, because that's wrong. Don't do that. I want r to be smaller than 11. I need all my r's to be smaller than 11. So which way am I shading? Left. And then it's an and problem, so I want the overlap. Negative 4 to 11. Do not shade the way the inequality points. That is not a good plan. Yeah. So the remaining 1, 2, 3, 4, 5, 6 problems would be your assignment.